Okay, good morning everyone. This is our live Google Hangout with Molex. My name is Pete Wood. I look after Design Spark, our engineering community here at RS Components. And my colleague here, Dave, aka Connector Geek.
Morning, yeah, Dave Pike. I look after marketing connectors.
Great stuff. And we also have Ian, in this doors far away from Molex. And Ian looks after connectors for commercial vehicle applications. So we're going to have a chat with him today about some of the things that we've got that fits into that industry sector. So Ian, over to you.
Thanks both. So today we want to talk about some of the key drivers, market trends, connector requirements, and the Molex solutions and how we fit into it. So commercial vehicles, we're talking about non-automotive transportation, so things like trucks and buses, construction, agricultural, rail and marine. So some of the challenges, Earth is obviously a closed system, so the resources that we have available today are the only ones we're going to have in the future. So we have a limited amount of water, sunlight and ground to grow crops and house people on. So as the population grows to over 9 billion by 2050, the challenge is really population versus resource. So we need to find ways of becoming more efficient and increasing productivity. So there's tight segment links between commercial vehicles and the population. One of the drivers is an increased standard of living. So countries such as Russia, India and China, this is on the increase. An example of that would be the meat consumption. So an average Chinese person eats around 110 pounds of meat per year. In the US, that's around 240 pounds. When you consider that the size of China is roughly the same as the US, North America, yet they've got to feed and house around 4 times the population. There's also an increased demand on public transport, so we're going to have to move more people. The product that they want, like clothes and food, also the building materials are all going to have to be moved. So how we're answering this is basically more electronics and making things more efficient. So precision farming is a key example where machinery is becoming larger and more efficient with the integration of GPS and cameras and LCD displays and incorporating things like crop sensing. So really looking at the ground, for instance, and the minerals that are in each area of the field. So rather than applying maybe pesticides or fertilizer to the whole farm, just doing where it's needed. So drones, for instance, are being used more and more, not only for land mapping, but also for applying some of those chemicals by spraying from above. Autonomous vehicles are also being used for increasing the efficiency. So like underground mining, for instance, where the vehicles can then operate 24 hours a day, 7 days a week. Telematics is another area where there's a large increase. So examples would be tracking of fleet. So that could be trucks, so that the owners can better manage the fleet, the mileage that each vehicle's done, and manage the service of each vehicle to get the most out of that vehicle. With the increase, there's obviously a need to keep the air a good quality for the human population. And as more and more vehicles are being introduced and emissions legislation is increasing, it's a challenge to reduce those. So on an engine, there's more and more closed loop feedback, more switch and sensors needed to provide that information. But electrification is also a big driver that's being seen in the market. So some manufacturers claim around 30% improvement on fuel economy, but there's other advantages such as the wear on the tires that can be seen. So the overall result is more power, more communications, and more standardization. But with all of this electronics, one of the real critical factors is that the sealed systems really need to perform. So any ingress in one connector could down a whole system and a whole vehicle with huge financial impact to the owners. likewise on signal integrity, if it's a sensor input, the last thing that you need is interference from EMC or EMI giving a false input. You don't want to drive under a power line and the vehicle go out of control. On the electrification side, the currents that are seen within those high voltage, high current cables and the earthing shield is really critical to make sure that those signals are grounded and that they don't interfere with other systems. So when we look at a ground vehicle, we can break it down into 4 basic areas. So powertrain, chassis and safety, telematics and infotainment, body and equipment. And no matter what the vehicle is, if it's a construction or truck and bus, the product that goes into each application and the connector systems are basically the same, no matter what the job is that the vehicle's performing.
One quick question for you on that, Ian. We're talking about sealed and unsealed connect systems. Are they the same system? Do you have a system that can do both, or are we looking at 2 different types of connector?
Yeah, so on some applications we do have to have different connectors. We do have some versions though, like the MX150, so we would have a sealed version, and we also have an unsealed version as well. So it's the same contact and the same tooling that can be loaded into each housing. So you can reduce the cost further if you do not need the sealing. Okay, so some key characteristics. So in commercial vehicles, we spoke about sealed connectors. So IP rating is very important. So IP67 is temporary immersion, 68 is continuous immersion, 69K is for the high pressure washdown, which is seen a lot more in the market today. So keying, this is a mechanical feature, so that if you've got 220 circuit connectors, it makes sure that you cannot mismate the 2 connectors, and you make sure that they're connected the correct way. Color coding is also something that's being required more and more to make that a lot easier for the operator. Environmental exposures to consider. So these applications where the connectors are, often they come into contact with a lot of nasty materials that can harm the connectors, so the seals can perish, and that would allow ingress into the system. So we have to be very careful with what materials are used and make sure they're fully tested and validated. A lot of the applications are high vibe, and so we would recommend in a lot of these connect systems that terminal position assurance and connector position assurances are used. So these are secondary lock features that lock the terminal in. And also the CPA gives you a visual that the connector is fully mated so that you don't have intermittency. And it also acts as a secondary lock. So on the temperature side, traditionally follows automotive with -40 to +125. But a bit more now, we're seeing more of a need for a wider range of temperatures. So down to -55 and up to 150 in some cases.
Ian, is there a key driver behind that extended range? That's a big leap in terms of capability. So what's driving that? Is that got an effect on the type of connectors, the materials? What commercial applications does that have?
Yeah, sure. So some of the drivers behind that are some of the engine manufacturers, for instance, to meet some of the tougher emissions legislations, are having to run the engines hotter. So that's one of the drivers behind it. And then from a connector standpoint, we do have to consider, the material that's used there. So it's not as easy as just changing the specification. Quite often we will need to change the material, and in some cases that might mean a change of tooling as well. Okay, so some basics on the seal connectors. So an older version would be the cable seal. So this is where you would have to put a grommet onto the cable. This relies on making sure you've got the right grommet for the wire gauge. Also, it means that you need to crimp it correctly and you don't tear the seal. And it also means that you have to make sure it's in place. So it is possible to crimp the cable without a seal and insert it. The other version that we're showing here is a mat seal. So this is where the seal is a one-piece design that's loaded into the back of the connector. Sometimes that's then held in with a rear seal that really keeps that within the connector. And then the interfacial seal is what makes the seal between the mating connector. So the critical sealing points to avoid ingress are where the cable goes in at the back, the mating between the two connectors, and if it's a bulkhead connector, you also need to make your sealing is adequate to the bulkhead. So how does Molex fit into this? Traditionally on electrification, a standard cable gland would be used. So often these larger diameter cables would have a lug crimped on them. And in many applications, you're not able to fit the lug through the cable gland. So you would have to put the cable through and then crimp and bolt it down and come back out and tighten that up. So for applications such as this one, which is an inverter bank, we developed the MAXLOG product. So this is IP67, 68, and 69K. It's suitable for 35 to 125 mil square cable, but you can crimp, offset, and centerline lugs like this one shown, and pass it through the body of the housing, bolts from the outside, and it's got extremely good shielding down to the ground. So another product that we have is shown here. So this is the Imperium. So it's a solid contact. So that's extremely good for vibration with 360 degree shielding down to the earth. And this is capable of carrying up to 250 amps.
Oh, 250 amps, that's quite a lot of current, Ian. What kind of size is that?
Yeah, so to give you a bit of a feeling for it, so this is the connector. So these two wires on the back, these go to our MX150 terminal. So this is used as a high voltage interlock. So here you can see there's a loop, so it can sense when the connector's made. So as soon as you mate it, it breaks the additional circuit, and that can then feed back to cut any current that may harm an individual that is putting their fingers near the connector. So you can see it's not a small connector, but you wouldn't expect that at 250 amps either. So on to communication. So the HSOR Link on the right-hand side is a US car 30 mini USB footprint. So this is limited to around 3,000 megabits per second. So capable of LVDS, 2-wire and 4-wire. But the industry is really needing an increase in bandwidth. So we developed the HSOR Link 2. This is a sealed and unsealed connector system. On the sealed version, it's IP67 and 69K and available in 6 and 12 circuit. So this has the increased bandwidth, so up to 5,000 megabits per second. So applications would be like displays, controllers, cameras. And one advantage is that you're able to run multiple protocols through one connector. Also on communication, we have a full range of product for more industrial, like Ethernet products. So we have M8 and M12 industry standards. Molex also participated on the SAE committee for the J2839 connector standard. So this shows you it's still an M12 interface, but the modification to the connector itself allows a 100-pound pull force in any direction for a minute. There's also an extra heavy-duty version, which is a lot more ruggedized, but allows up to 300 pounds for 1 minute. So this is really, in applications where the cost of the vehicle being down due to a system failure warrants having this type of product. In the M12, we also have product like the CHT. So here we've integrated data for the signal and also power. So this is available as a 4+4 and also a 4+2. So this simplifies the cabling for manufacturers. And with the 4 power lines, we can carry 6 amps, and with the 2, we can carry up to 12 amps. We also offer a full range of Ethernet switches. For commercial vehicles, we would have this one, which is IP67 rated. We've recently released the MLX-T, which is a fully intermatable product with the industry de facto standard. So this is IP69K and UL approved. We have an 18-circuit wire-to-wire version. And one of the big improvements here is really on the sealing. So we discussed the critical factors on a connector. And what we've done is we developed a technology here to make the plug-in housing and the seal one piece using a 2-shot process. So that seal isn't going to roll or fall off or move during mating and unmating to really ensure performance. It's also available in a multitude of colors, as seen at the bottom. The SRC is a bulkhead connector, mainly for firewall applications where you're going from maybe outside the cab onto inside the cab. And this is a hybrid system, so it uses our MX150 terminals, which carry up to 22 amps, and the MX150L up to 40 amps. Obviously have to apply some derating to a fully loaded system. But here you can see that these inserts are changeable, so that we can go from an 84-way signal only all the way to a 20-way power only. So we have everything in between. So here you can see the 60 signal plus 6 power. Obviously, in this market, the back shells are required to the conduit, and they're fully available. So here's a quick overview of some other product, and for more information on any of those or what we've spoken about today, you can follow the link molex.com/CV, which will take you straight to our commercial vehicle page.
Great, Ian, thanks for that really good overview there. Some great products, some great example applications. So we're going to take some questions. If anyone is watching live and they want to chat us a question, please do so. We've also got some questions here to ask you that have come in already, and some that we've got for ourselves. So while we're waiting for any questions to come through, Dave, we'll kick off with you.
Certainly, yeah. Looking at the MLX-T, we talked about the 2-shot molding process. And talked about how that makes the seal more secure. Can you show us what it actually looks like in place? Yeah, sure.
So, I can show you a few examples here. So this is the 18 circuit that we spoke about. So on some, let me just show you some other features. So on the other types of connectors, the mat seal is often exposed at the back. So what that means is when the cable goes into the connector, if there's a pull on the harness, it means that you can open up an ingress path down the side of the seal. On this type of product, the MLX-T, you'll see that the seal is embedded further into the connector, and we have the rear cover that's holding that in place. But this cancellation effect, it also means that any bending on the cable, the bend radius is far enough away from the seal that there isn't an ingress path down the back. Now on the front, when we move to this seal, you can see that it's a one-piece assembly like we discussed, but that isn't bonded with a glue or anything like that. We worked on a technology, so this is an example of the seal material, and this is the same plastic as the housing. And we developed the technology that bonds those during a molding process to make sure that seal is in the right place, it's not going to move, and it ensures performance and seal integrity.
Fantastic, thanks. Somebody else has also asked about the MLX-T, which looks similar to other, should we say, industry standard connectors, and they wanted to know, can they use their existing application tooling? Is there a new tool they need?
No, that's correct. So it's fully intermatable with an industry de facto connect system. The tooling, you can take our terminals and run them through existing tooling at harness houses, for instance. And there can be a change of contacts as well with the housing. One thing we do recommend on the 18 circuit, though, is that the Molex terminals are used to meet some of the insertion forces. So that is something to consider.
Okay. You mentioned, Ian, about the HSOR Link 2 and about being able to manage multiple protocols. What does a cable assembly look like that might manage something like that?
Yeah, okay. So give you a bit more of an idea. So typically, coming out of like a control unit, if you're wanting to handle USB and Ethernet, typically you would have to have 2 connectors on there. So this would show the 12 circuit HSOR Link 2. So one connector will go onto the housing, and then after that we've got the 2 cables which handle one going to Ethernet and one going to USB.
Oh, fantastic.
So both of those coming from one header.
The other thing was, you mentioned about autonomous vehicles. What kind of applications does that fit into? What have you got any examples?
Yes, I guess another example would be in agriculture, where you can have a combine driving along a field with a tractor that's got no driver in it, collecting the crop from the combine. Or another application on trucks would be the recent tests that they've done, where there's been one lead truck with a driver, and the vehicles following behind in convoy have been driverless.
Cool. Okay. I've got a question here about how customers can integrate connectors into effectively their custom design. Is that something that you guys could help with?
Yeah, so there's depending on the type of connector that's needed, there's various options that we would have. So for HSOR Link 2, for instance, if it was for a data requirement or an M12, we do sell just the insert so that can be incorporated. Some product like the MX150, for instance, so this interface is a US car standard. So the drawings for this interface are all available on the website or from Molex to tool that up. Now, additional to that, Molex do also sell like the pin headers, unshrouded pin headers. So if somebody wanted to buy those and incorporate those into their product, that is also an option too.
Okay. And I've got one other question here, specifically somebody seen the SRC connector and saying, is it just for commercial vehicle applications, or is this something that could be used elsewhere?
So predominantly it was designed for, and its main uses are for commercial vehicles. But no, absolutely not. It's not restricted just to commercial vehicle applications. So maybe in an industrial application, if you're connecting to a cabinet with a PLC inside or something like that, this could be an option where you could have that as the panel mount, and then you can connect up to 84 circuits with a simple sliding latch.
Fantastic, thanks.
Great. So I don't think we've got any more questions, just looking at the feed here. So great, Ian, thank you so much. Really good overview there. If anyone's got any questions, we're going to put this video up onto our YouTube channel, so you can leave any comments underneath there to ask questions, and we'll monitor those. But again, great. Thanks for joining us on the live Hangout, everyone. And of course, Ian, for presenting. And we'll see you again next time.
Thank you very much.
Yes.
Thanks, Ian.
Cheers.